Welcome to the third part of Introduction to Social Network Analysis. In part 3, I'm going to talk about some measures and models. The measures are used to describe the network. You also see researcher calculating some measures such as centrality or betweenness and then taking those outputs and putting them into linear regressions. This is often done when the network is the independent variable, but not all researchers recommend that. The models try to explain the presence or absence of ties using the network as dependent variable. There are many ways to describe a network. The number of actors, so the number of nodes, and density, so the number of edges, are often mentioned. In addition, one often used measure is centrality. It captures how powerful an actor is. Power in the sense of how fast can a node reach other nodes, or how many nodes can be influenced. As you can see, there are many ways to calculate this power, and you need to use theory to select what centrality measure best explain what you want to measure. I will demonstrate a couple of those centrality concepts. This figure is from Alberto Manuel, enterprise architect at Microsoft. It shows 4 different types of centrality. Let's pick out 2, nodes J and H. Node J has the highest degree centrality. That means it has the highest amount of ties being directed to it. Node H has the highest betweenness centrality. That means it is the node that most often connects 2 different nodes. If you compare node H and node I, you can see that node H has one more tie than node I. Everybody who wants to reach node R needs to go through H. Now imagine that node R is a senior CEO, the power node H has. Of course, there are more network measures you can look at. For example, there is structural equivalence, which looks at if 2 people have the same network position, so if they are connected to the same people. Then there are different versions of this equivalence. Or you can calculate the amount of external and internal ties, so the amount of ties to a group and to the outside group. Or you can look at clusters in it, so do you have subgroups in a network? To wrap up part 3, here a quick overview of a few models that take network as a dependent or independent variable. What they all have in common is that they try to account that the tie Tom to Jerry is not independent to the tie Jerry to Tom. As the observation in networks is not about people, Tom and Jerry, but about the relationships between people, Jerry to Tom and Tom to Jerry, these models try to control for this dependence. So, shortly, there are a couple of exponential random graph models, in short, ergms. I say a couple because you have ergms for standard networks, but you also have them for bipath networks or for longitudinal networks and for multi-level type of data. Then you have multiple regression quadratic assignment procedures, in short, MR-QUAP. This is your linear regression taking networks as a dependent and independent variables and controlling for the dependence between actors. It also takes value data, but does not allow you to control for network effects. It models those effects. Then there are stochastic actor-based modeling, SOA. This is a longitudinal model with which you can explain why a tie is being created and maintained versus terminated or never created. If you have enough data, you can also make a distinction between what factors influence the creation of a tie compared to the maintenance of a tie. And then there are models that try to explain how your network position influences a behavior. So this is often done with peers, how your network position influences if they're smoking, yes or no. And these models, they are for cross-sectional and longitudinal data.